If I were to ask you who the greatest scientists in history are, especially in the field of physics, those monumental figures who opened and closed entire eras, who would come to mind? Which names are you thinking of? Max Planck, Niels Bohr, Werner Heisenberg, Erwin Schrödinger, Max Born, Alessandro Volta, Hans Christian Ørsted, Alexander Graham Bell, and many more. But if we stopped a random person out on the street and asked them, even someone who has had at least a bit of physics education in school, the first names we would most likely hear are Isaac Newton and Albert Einstein. But what about the third? That's exactly where people begin to hesitate, to struggle, and often they can't even come up with an answer at all. Yet, hidden between the lines of books, there exists a third giant, one that very few people truly know, and even those who do often fail to give him the credit he deserves. A man who is in no way inferior to Newton or Einstein. In fact, perhaps the very person who made Einstein. Einstein. Someone Einstein admired so deeply that he hung his portrait on the wall of his office, James Clerk Maxwell. Einstein once questioned how well we truly understand Maxwell and then said, "Everything is usually associated with the theory of special relativity. Yet the foundation of this theory lies in Maxwell's equations of the electromagnetic field." And he added, "Since Maxwell, physical reality has been described in terms of fields rather than particles. This is the greatest revolution in physics since Newton." Ivan Tolstoy, who wrote Maxwell's biography, once said, "Maxwell's impact on the history of science is as great as Einstein's, and in some sense, as great as Newton's." Professor R.V. Jones, evaluating Maxwell's electromagnetic field theory presented to the Royal Society, stated, "This work provided the first evidence for the existence of radiation, along with light and heat. It is one of the greatest steps in the history of humanity." Max Planck, the man who ignited the spark of quantum physics, said of him, "He accomplished things that had never been seen before," and perhaps one of the most beloved teachers in history, Richard Feynman, once said about Maxwell, "When I think about the future of humanity, even 10,000 years from now, when people look back at the past, they will see Maxwell's discovery of the laws of electrodynamics as the most significant event of the 19th century." These are some incredibly powerful endorsements, aren't they? And yet, Maxwell is rarely mentioned. He is seldom given the credit he truly deserves. It's hard to say exactly why, but at one point he himself said, "Those who wrote history probably didn't fully understand what I had done, and because they didn't understand it, they overlooked it." So, can someone who receives this level of praise really be ordinary? What did he do to earn the respect of such great minds? Come, let's give Maxwell the credit he truly deserves, because his story, much like Michael Faraday's, has so much to teach us. In fact, that's exactly why I made a video about Faraday, because Maxwell's story doesn't start from nothing. It begins where Faraday left off and is built upon his foundation. There's even an interesting detail. When Faraday announced his discoveries on electricity and magnetism, the year was 1831. That was the same year Maxwell was born. Maxwell passed away in 1879, and in that very same year, Einstein was born. Of course, this is just a symbolic coincidence. But when you think about the continuity between the theories of these three minds, it becomes incredibly meaningful. By the age of just 14, Maxwell had already published a paper on geometry. Everything he saw, every question in his mind, he tried to explain through mathematics, and he did it with extraordinary success. By the time he entered Cambridge at 19, he already had 3 published works, and in his early 20s his name was already being recognized in the scientific world. You know the rings of Saturn, one of the most fascinating formations in the solar system. But for centuries, no one had been able to fully explain what they actually were. Some believed they were liquid. Others thought they were a single solid mass. In 1857, a competition was announced to solve this mystery. A reward would be given to whoever could explain it. And then Maxwell stepped onto the stage. He demonstrated that these rings were formed by millions of tiny particles moving under the influence of gravity, and proved it with an extraordinary mathematical model. Look, saying it's made of particles is one thing, but proving it with mathematics is something entirely different. And here's the striking part. He was the only person who entered the competition. This achievement instantly made him one of the most important theoretical physicists in England. At just 25 years old, he became a professor. But Maxwell didn't stop there. He began to think about colors. Isaac Newton had explained the origin of colors, but he had not fully revealed how they mix. This subject was not deeply explored for nearly 150 years. Only Thomas Young had proposed a theory. The human eye contained receptors sensitive to 3 primary colors, and the person who took this idea and expressed it mathematically was once again James Clerk Maxwell. Through his color wheel experiments, he demonstrated how colors mix. He developed formulas that calculated which colors would be produced in which proportions. The person who laid the foundation of the RGB system you see today in Adobe Photoshop was him. And there's more. He was also the person who took the first color photograph in history. When he projected this image onto a wall during a lecture at the Royal Institution, people were utterly mesmerized. That moment was the beginning of all the screen technologies we use today. He was only 29 years old, but his life was not easy. He lost his mother at the age of 8, and shortly before becoming a professor. He lost his father as well. He was a solitary character, a man who wrote poetry, emotional and introspective. Then Catherine entered his life. He proposed to her with a poem, and they got married. For a while he was unemployed. He worked as a farmer. He was rejected by universities. But eventually he began working at King's College London, and this is where the real story truly began. Electricity and magnetism. Humanity knew these two forces separately. The first person to recognize the connection between them was Michael Faraday. But Faraday could not express this relationship mathematically, and this is where James Clerk Maxwell stepped in. He unified these two forces and revealed the 4 fundamental equations we now call the Maxwell equations. These equations were telling us something profound. Electricity and magnetism were not separate. They were 2 different faces of a single structure. But the real breakthrough emerged when these equations were brought together. The result was approximately 300,000 kilometers per second. That is, the speed of light. What did this mean? Light was an electromagnetic wave. This discovery shook Isaac Newton's understanding of physics to its core. It changed the way we perceive the universe. But James Clerk Maxwell had a problem. He could not prove it experimentally. Just as Michael Faraday struggled with mathematics, Maxwell struggled with experimentation. And the scientific world once again responded with skepticism. Until 20 years later, when Heinrich Hertz experimentally proved electromagnetic waves. That's when everyone finally understood. But at that moment, a question was asked. What is it good for? Heinrich Hertz's answer was short and clear. Nothing. But today we know very well how wrong he was, because those waves became radio, became television, became radar, became microwaves, infrared, ultraviolet, X-rays, gamma rays. They became the foundation of the modern world, and all of it was born from James Clerk Maxwell's equations. But Maxwell never lived to see any of it. In the final years of his life, he founded the Cavendish Laboratory in University of Cambridge. This laboratory would go on to host dozens of Nobel Prize-winning discoveries in the years to come. But James Clerk Maxwell, like his mother, at a young age, he passed away at the age of 48. A short life, but an infinite impact. Today, more important than technology itself, is the perspective he gave us. We are no longer trying to understand only a world we see, but also the invisible universe. And with this series, we are trying to tell that journey. Before the formulas, the story. Maybe it will inspire someone. Maybe it will move someone to act. Or maybe one of us will change the world. And as always, until we meet again, I'm glad you exist. With love.